Good afternoon, everyone, and welcome to Tuesdays for Teachers, taking the struggle out of science and those science short answers. I'm Bonnie Goonan, and with me today are Daphne Atkinson from the GED Testing Service and Susan Pittman. Today, as we go through, what we're going to be talking about is the importance of students' understanding of the scientific method. And we're going to do a little bit of work on investigating some strategies that you can use in the classroom to help your students respond to science short answer items. And of course, as in past, we're going to share some resources and ideas. As we go through today's Tuesdays for Teachers, if you have questions, please go ahead and just put those into either the question or chat box. What Susan and I will be doing is we'll be looking at those questions throughout so that we make sure that if there's information you want to know, that we will get that information answered. So before we get started, Daphne, Susan, would you like to welcome the group?
Of course. Welcome. Daphne comes before Susan, so Daphne.
Okay, thanks, Susan. Welcome to the last Tuesdays for Teachers for 2016. And for those of you who made this a regular stop on your professional development circuit throughout the year, welcome back. To those of you who may be new, welcome. Understand that if you're new, we have a complete webinar archive on GEDtestingservice.com that covers all of the webinars that we've done for 2016 and also 2015. Get ready for a real treat. Thanks for stopping by, and I'm going to turn it over to Susan.
Thank you, everyone, for being here. Just a couple of housekeeping things before we go a little bit further into this. Everyone is muted. That is so we don't have any background noise that is going on. But as Bonnie said, if you have a question, please feel free to type that into the question box, and we'll be monitoring those as we go through. The other thing is that you have two handouts that if you haven't already accessed those materials through one of the email reminders that you received, you can do that right here on the site itself. If you look, you'll see there's a tab that says Handouts, and all you have to do is open that and you can download those. So if you don't have your handouts already, this is certainly something that you can go ahead and do at this point in time. So having said that, Bonnie, let's let her roll, and let's start out with a great quote from Carl Sagan, that science is a way of thinking much more than it is a body of knowledge. And you know, that is so true when we look at what all is out there and what our students need to do, because their first thoughts, unfortunately, when they hear science is, oh, I don't know that table. I don't know these laws of motion. I don't know these certain things. It's not just about this content, but it's how you can think as an individual. So let's talk about one of the important things here, and that's science practices, because that's at the heart of what you see on the GED test. It's about being able to look at the real world and observe and experiment, measure, and test. It's about how we investigate and we evaluate all of those higher order thinking skills that are out there. It's about reasoning and calculating and planning. And if you take a look over at that right-hand corner at the bottom, you see that word hypotheses. Formulate hypotheses and propose solutions. That's something that really is going to become important as we look at those science short answers, which our students sometimes have some problems with. But, you know, the GED Testing Service has done an incredible job in looking at and doing research on how students are doing, where they're having challenges, and that gives us some ideas of things that we can do as instructors to help students increase those scores on their science tests. And if we look at the high impact indicators, remember those are those things that really can help students across the board. I think you see some of the same words appearing. identify and refine hypothesis. Look at those terms there, independent and dependent variables. I think we hear those in math as well. But looking at it from scientific investigations, whether or not we can evaluate a conclusion or put in scientific information and express it visually. Looking at something that visually sounds to me like maybe we have some graphics that are included in there, and applying formulas from scientific theories. But okay, let's dig, Bonnie, a little bit deeper into that, and let's look at this from a standpoint of what does it look like when students are doing that work. And we're focusing today especially on investigation design, because that helps not just when students go to write a short answer, but it also makes a big difference as they're answering regular questions, just those multiple choice questions, as a matter of fact. But look at what students should be able to do. What should you see in students' work? That they can identify a hypothesis, that they can differentiate between one that's good and one that's poorly conceived, that they can identify it for a given data set, or maybe they can look at that independent and dependent variable within a given investigation. And even more importantly, can they see the relationship between those variables? So if we take a look at that, that really tells us, okay, we need to focus in on what we see as the scientific method. So, okay, I said that, it is important when they're doing one of the writing samples for one of the short answers. But Bonnie, if we take a look, we see that there's something that we do just with a science sample question. So I think when I look at this, I go, okay, if I look at what the questions ask me, it says, which hypothesis would be better for the researchers to use? So they've been given some information, and now they've got to determine which one would give them that results that they're looking for, which one would be the best. So it's not just about that scientific design question, but it's also about doing this within the entire science test. So Bonnie, is there something we can do to help build students' scientific reasoning skills?
There definitely is, Susan. Now, we know that just like Susan and I, you may not have a science lab. But guess what? We can do experiments in the classroom, one experiment at a time. Because what we want our students to be able to do is we want them to be able to evaluate whether data supports a hypothesis. Very similar to that question that we were looking at previously. We want to be able to know that our students can identify variables in an experimental process. We also need to make sure that our students can determine a method for collecting data and draw a conclusion based on that data that's been selected or collected. We also need to ensure that students need to be able to determine the correct process for an experiment. As Susan said, not just for the short answer questions, but also for the other technology enhanced items. And can they create a hypothesis and design an investigation based upon that hypothesis? Now, as I said, most of us do not work in a lab. In fact, we may not even have that type of setting for our students to use. But guess what? The scientific method does not just exist in a lab. The scientific method or experimental design also works in real-world applications, and that's really where we should start. Now, when we look at different graphics of the scientific method, I know sometimes certain graphics say something slightly different. But the bottom line is that the scientific method starts with observation and research, then goes into constructing a hypothesis, testing it, analyzing the results, and determining whether that hypothesis is true or not. As I said, sometimes we think about, oh gosh, it must be some experimental design about the latest vaccine or something similar, but quite honestly, the scientific method happens every day. Susan and I, the other day, we were on the road and we observed that the car wouldn't start. Do you remember that, Susan?
Oh, I remember. Absolutely.
Yes. We got
You
into the
get in, you
car
get in
and
that
we tried
car
to
and
turn
you
the key.
turn the key and nothing. And then you think,
Absolutely nothing.
oh no, what am I going to do?
Well, I think we used the scientific method actually, because we both determined that there was something wrong in the car, and we predicted some of the reasons maybe the car wouldn't start, such as, oh gosh, we looked up on the top and that little light on the ceiling was on, so it had been on all night. So maybe the battery was dead enough that it just wasn't going to work. And gosh, I remember that we tried to put that key in and didn't quite turn right. So maybe there was an ignition problem, or perhaps we were out of gas. So we had all these little different hypotheses or predictions, and we decided if we were going to do anything to get that car started, we needed to test those predictions. So if I remember right, you turned on the headlights and then you
Uh-huh.
checked the spark plug wires, and then we opened up the gas tank and tried to see if we could get something down there to see whether there was gas or not. And as we tested things, we analyzed the results. You turned on the headlights and guess what? The headlights worked. And so we decided can't be the battery. Well, we also checked the spark plug wires and we found out that there was an ignition spark. So guess what? We analyzed those results as saying nothing wrong there. But as we were trying to check the gas, even though the gauge said it was half full, we couldn't see any gas in the tank and we couldn't get any gas on that dipstick. So we had to draw the conclusion that that gauge was inaccurate. And sure enough, once we put gas in the car, it worked. That's a scientific method. And
And
that's
we
what we
also
need to do with our
and we
students.
also learned too that we'll try a different rental car company the next time as we go through. But I
Oh,
have to tell
definitely.
you that one thing that Lisa Plummer just said, she said, it's an excellent point. She says, we use it in the grocery store every time we consider purchasing a new food to eat. She's right. We do. We
Exactly.
hypothesize and we use the process. And I think, Lisa, from that perspective, as we're looking at things, it's one of those cases that sometimes it's just that simple, that our students need to see that it's something that is not this far out there, really hard to understand thing, but it's something that's a part of our lives. And we don't know it. We don't even recognize it at that point.
So true. So let's take just a few moments before we really look more deeply at the scientific method at each of the segments of the scientific method or investigative design. And of course, any good design has to start out with the problem, observing or defining the problem. And that can be something as simple as a question. Does exercise make your heart beat faster? I don't know about you, but for me it does. But the problem is, does it? Or that question we had previously, why is the health of the desert biome deteriorating? That may be the beginning of the investigation, but there's a whole lot more to it. So, Susan, how about another real-world scenario?
Okay, let's take something that, hey, this happens in our homes. Okay, so John noticed that bread stored in an area that was dry did not mold as quickly as in an area that had more moisture. Okay, so he's seeing that. Now he's going to say, okay, why is that happening? Does bread mold more quickly under different storage conditions? So he's made, an observation. He's beginning to ask questions. But what he's going to need to do next, Bonnie, is he's really going to have to come up with a hypothesis. And, that's really an educated guess. It's about how things work. It's a prediction. And many times our students are, just like we did with the car that wouldn't start, we were predicting what might be. And generally, if we're going to write a hypothesis, we use those if this, then this will happen type of statement where we're really focusing on one variable only. So let's go back to what John had to say about the bread in his question, and let's put a hypothesis together for that. So here's our hypothesis. If bread is stored in a more humid area, then it will mold more quickly. okay, sounds pretty good to me because, it is a prediction. It's an educated guess. But you know what? We're going to have to go a little further than that because we really need to see the because. Why is this going to happen? So let's expand it out just a little bit, Bonnie, and let's try this. If you have dry bread and moist bread are left in bags for 2 weeks, the moist bread will grow mold more quickly than the dry bread because mold is a living organism and organisms need water to survive. Bonnie, could I test that?
I think that would make an excellent experiment, and I could do that in my classroom very easily because I could set up a procedure and determine the materials I need. And you also said that if they're left in bags for 2 weeks, the moist bread will grow mold more quickly. So I have an outcome that's going to be measurable as I look at that mold. So that gathering evidence and experimenting, that's going to be really, really easy to do, I think, for what you've just told me. So very specifically, I set up the experiment. I include a detailed materials list. I'm going to need slices of bread that are exactly the same. I don't want some white bread and some wheat bread and some white bread or some rye bread. My method of storage is going to have to be exactly the same. My location of storage. Why in the world would I want the location the same?
Well, I got to see how it's going to impact it because I don't want one to be affected by maybe being near a window and has more light that's coming in, which might change the moisture level. I want to make sure that I've kept my conditions the same so that I have to control part of this experiment. I just can't have all kinds of weird stuff out there. So if I want to be really scientific in this, I need to make sure that I'm doing things that aren't going to have some other kind of impact rather than what I'm really trying to measure.
Okay, so I started with the observation and prediction. I formulated a hypothesis. I've now gathered the evidence and I've determined how I'm going to do everything. So I guess it's time now for me to take this short experiment and actually do it. And after I do it, this is one of the parts that I find students had the most difficulty. It was the fact that they would do the experiment, but they wouldn't record the data. They didn't quite know qualitative versus quantitative. They didn't know what kind of information that they should chart. Oftentimes, they didn't even know that they should chart a similar thing in a specific time frame. So with this particular real-world experiment, I would want to make sure that my students knew that they could use a data chart, that let's say they checked the bread daily. They would then record either no mold or if there was mold, specifically how much. Because without this information, they wouldn't be able to analyze results. So when we look at this type of a chart, this is what we would expect students to understand in how to collect and analyze results. Really, really important, again, not only for short answer, but in the technology enhanced items, if they're faced with a chart of data and they're asked questions such as, how would you interpret it? They need to be able to do it before they interpret it well. So take a look at that, Susan. I noticed that we have things for days 1 through 5. Would there be any conclusions that you could draw? Because we know that you have to look back at the hypothesis. You have to analyze the data to see whether that hypothesis was accepted or rejected. And if it was rejected, if there were possible reasons. So if I remember right, you said if bread's stored in a more humid area, then it will mold more quickly. So I'm going to go backwards and say, based on that data, what could you conclude?
Well, considering the fact that even on day 3, I'm not even through 5 days of it, but on day 3, I'm already finding a small spot of mold on the corner of bread that's in the humid area. Now, day 4, I've got some mold on the other bread, but whoa, look at what's happening with the humid area. And go on to day 5. So I would say that based on the data collected after 5 days, it clearly demonstrated that bread stored in a humid area molded more quickly than that stored in a dry area.
You know, that's exactly right. And although this particular experiment may seem simplistic, it provides everything students need to know about scientific design or the scientific method. Many of our students have never had the opportunity to experiment, and Susan and I strongly believe that unless they can go through that step by step, it's very difficult for them to evaluate or interpret answers on the short answer questions. So, having said that, any comments from the field on the process before we get started, really digging deeper into how scientific information is used for short answers?
Well, I think we had one here that from Wendy, who said many describe a hypothesis as a guess, which she says seems to be kind of an arbitrary term. Would it be more accurately described as an assumption or prediction? And I think that's true. Yes, it can be an educated guess, but for our students, it is about a prediction, and then have students find their own correlations as to why they think something happens. So I think that's a good point that Wendy brings up.
You know, it really is. And we have, as I'm looking through a number of resources coming up, which we're going to share some more with you. But Amy talks about schooldiscoveryeducation.com, lots of project ideas, but also virtual labs. And virtual labs are a wonderful way to teach students the scientific method because it gives them so many realistic types of things. And Susan talks about Dan Meyer using a similar approach with starting with a question or observation. So lots of good support from other experts in the field about how do we really do this in the classroom. So great ideas, keep them coming. But one of the things I know that many of us have been concerned about, and our students as well, is the aspect of short answers. Because as Susan and I like to say, each short answer is individually worth up to 3 points, 3 raw score points, which means it's worth about 15% on the science test. And if students answer them, again, they have the ability to obtain those types of points. You know, very simplistically, if each question is worth up to 3 raw score points, we sure would never tell a student to skip 3 questions. And yet that's what they basically do if they won't answer short answers. And
Bonnie,
we know there's...
Let me ask you a question, though, before we kind of dive into the short answers itself, because when we get our, we have these wonderful enhanced score reports, but are we going to are we able to access what the student actually scored on those short answers?
No, Susan, we're not, because they are just part of the test. Because what GD Testing Service is looking for on the short answers is whether the student was able to effectively answer the question or not, as opposed to RLA, where they're really assessing multiple things, from trait 1, which is, the claim and evidence, to trait 2, which is organization development, to trait 3, sentence structure, grammar, etc. Here, it's whether the answer is correct or not, just like all the other technology-enhanced items.
Then listening to that, then I think it becomes even more important that that we, as instructors, go through, and when students do GED Ready, that we really analyze and we can use the scoring tool in order to do that, but that we really need to analyze that student's writing to see how they're really responding to things.
You know, that's so true. And what you and I have found as we've worked with this test is that the short answer items really are no different than the types of short answers you and I grew up with in school. These just happen to be, quote, science short answers, having that academic area. So talk to us a little bit about this first one. It says it's a narrative-based short answer. What in the world does that mean?
Well, that really means that you're going to take text. It might be a narrative, or it could even be from a chart or table, but you're going to take information and you're really going to analyze that. You're going to examine that text itself, and you're going to look at the relationships in the text. And you know what, Bonnie, that word relationship is really important, because that's going to help lead that student to a correct answer. And you're going to have they're going to have to provide an explanation. And you know, there's that evidence word one more time. We see it all the time in RLA, but now we have evidence that they need to cite from the text that provides that explanation. So having said that, I know sometimes that you hear those and you go, well, what does that really mean? So let's go back to the item sampler, and let's take a look. And this one, many of you have seen this over time. But let's really take a look at one that we can work with students. So notice on the left-hand side, of course, we have our source text. And in this particular case, there are 2 tabs up there, so we know there's 2 pages of it. And then we have, on the right-hand side, we have our prompt. And it starts out with really a definition. Deforestation, or clearing away trees, is occurring in tropical rainforests. So even if the student didn't know the term deforestation, there's the definition given. So now what is the student going to have to answer? Well, it says, explain how deforestation could disrupt the life cycle of the Ophiocordyceps unilateralis. I'm only going to say that once. In tropical rainforest. Include multiple pieces of evidence from the text to support your answer. And then you've got to type in the response, and it takes about 10 minutes in order to do that. Well, Bonnie, when I look at that, I'm reminded of something that we do with RLA, and that's analyze the prompt, and we unpack that prompt. So if we were to use the same table, that do what chart that we've always had, we focus in, again, on the verbs. Underline those or put them into the chart, those verbs, and look at what action is to be done from that verb and complete the chart. So we have to explain what? How deforestation could disrupt the life cycle. We've got to include what? Multiple pieces of evidence from the text. So that tells me I have to have at least 2 pieces, Bonnie. Then I have to type my response, and I should be taking about 10 minutes in order to complete this, because it really is a short answer. So if I do that, that means I need to go back and I need to analyze my source text. Well, I had some key words in that prompt. One of them was deforestation. The other one was that fungus, which the O unilateralis. That's how we'll shorten it for the time being. So what do I need to do as a student? Well, I need to closely read the text. But notice what we did first, Bonnie. First, we went through and we analyzed the prompt. We unpacked that prompt to say, okay, this is what I'm looking for. I go through and I look at things and I highlight keywords. Well, I know what my 2 keywords are, because I've got to find those relationships. And now I need to find the relationships in the text that put it, the O unilateralis with other organisms. I've got to connect deforestation to the fungus, and I've got to look at other organisms and deforestation. So I've got several different things I have going on there. So that leads me to saying, okay, let's look at some relationships. And I think we have a little graphic here that kind of shows all the different things. If you haven't read the actual source text on this in a while, you may want to go back and take a look at it. But basically, what we see is there's these relationships going on between O unilateralis, carpenter ants, and trees. And now we know that trees are important because we're talking about how's deforestation or losing those trees going to impact everything. So I need to know how all this is related. Well, my O unilateralist, the spores can't grow on the ground. They have to have trees. Okay, that's one relationship. The ants' nests provide the place for the spores to grow. So there shows another relationship. Well, where do those ants make their nests? They make them in the trees. And now this fungus keeps that insect population under control and prevents the loss of trees. So you see how, Bonnie, everything in this is all related together? That's how now I can explain that relationship between deforestation and that fungus that I have. So now let's see if I can't come up with something that I can, a little response to this. So I've shown my different relationships that I have. So now I've written a response. And keep in mind that all responses do not have to be this long. However, let's see if you look at this particular response and you think I've covered everything. So O unilateralis is a parasitic fungus. It feeds on carpenter ants. The carpenter ants make their nests in tall trees in the tropical rainforest. The O unilateralis require the right light and humidity to produce the spores. Now look at the rest of the relationship. The ants provide the right environment for the fungus. So if you get rid of, if the ants live in the trees and the trees are gone, well, then the fungus wouldn't have anything for food and its environment. And if that happened, guess what happens to the carpenter ant population? They're just going to go crazy. They'll go unchecked, which then creates other problems as we're going through there. So I've explained because it wanted to see those relationships in there. So now as I take a look at it, I go, okay, how could I earn points? Well, in this particular one, as Bonnie said earlier, you can earn up to 3 points. So take a look at this example that we have provided, and this is an example from the GED Resource Guide for Science. And as I take a look through it, if I want to get the maximum number of points, it has to be clear, well-developed explanation with complete support from the passage. Okay, deforestation would rob O unilateralis fungus of both its food and environment, thus endangering the fungus. Sounds like I got a good explanation there. And then if I go through, look at the things that are highlighted. That's all support from the passage itself. It feeds on the carpenter ants. It needs trees in order to produce spores. The carpenter ants make their nests in tall trees. It requires the right environment. So if I take a look at those, Bonnie, I think that one pretty much goes to the top of the list in all these things.
You know it does, Susan, but you gave so much evidence from the text, and it says multiple. So how much would I really need to give?
Well, if it says multiple, I at least need to give 2. But I don't think I'd have to go further than that. And that is where we've seen responses that are shorter than this. But again, what do we want to do? Notice that word there that says complete support from the passage. We really want students to be able to score at the top of this. So they first have to identify those relationships. Then they have to make sure they've got something that supports that. I think very easily many of our students could do this. They just need some practice in working with it.
You know, that's so true. And for those of you with us, if you've not read the different answers that GD Testing Service has provided, Susan has just shown you one that got all 3 points. But when both of us have looked at what gets 1 point or even 2 points, looking at minimal, looking at adequate or partial, it doesn't take a lot for students to get their points as long as they answer the questions. So here again, this is a higher level short answer, but a good example of what students need to do. And I don't know about you, Susan, but I think my students could have done something similar, if not quite as complete. I think I could have gotten at least.
Yeah, I would agree with you there. The thing that the real issue here is, can a student analyze the passage that they're reading? That's
True.
really what it comes down to. Can they analyze and can they find those relationships? And if they can do that, they're home free.
And nowhere that I have found does it say how many sentences or how many words should be in the answer. It just comes back to have they met the prompt. So unlike RLA, where GD Testing Service is expecting a larger piece of writing, in science it really is about how well the prompt is answered as opposed to length, because you and I have seen some very lengthy answers, but lots of words, they don't answer the question.
True, true. But Bonnie, there is another type of short answer, and that one comes back to that experimental design that we just talked about. So, in that particular short answer, they've got to describe an experiment to test a specific hypothesis. Now, they don't have to create that hypothesis. It's there for them. But they've got to put that experiment together just like we did with the moldy bread. But they've also got to have a way of collecting data. They've got to be able to describe that and justify that process. Would that actually prove or disprove the hypothesis? So let's take a look, and how about taking us through the one we remember so fondly, the farmer.
Oh, definitely. And it is again about scientific method. And this particular one talked about a farmer, and his hypothesis was that using either method will reduce soil erosion compared to using traditional farming methods, plowing and no cover crop. And so what he was going to do was, what we needed to do was to design a controlled experiment that the farmer can use to test his hypothesis. Include a description of data collection and how the farmer will determine whether his hypothesis is correct. So, first steps first is we want students to unpack that prompt. Analyze what they're to do by looking at those verbs. And when I look at those verbs, it shows me very clearly that I need to design a controlled experiment. I need to include the data collection description, and I need to determine whether the hypothesis is correct or not. Then I need to look at those keywords from the prompt. And I need to think to myself, okay, what kind of experiment would I design? How would I collect the data, and what data would I collect? And how would I evaluate whether it's correct or not? Sometimes it's easiest if our students can just go ahead and analyze the source text and take a look at what are those steps in the scientific method. What do we know and what do we need to figure out? So that first step in the scientific method, to observe, as I read, I notice that the field includes 30 acres. The topsoil is about 20 centimeters in thickness, and the farmer knows that two methods can be used to reduce soil erosion: no-till and winter cover crop. And yes, it is acres, not acres. Anyway,
Actually, we did well with having two
yes,
arrows and one little portion there.
So the hypothesis, and this comes from the farmer, is that he believes either method 1 or 2 is going to be better than the traditional method, plowing and no cover. So we have all of that information, and then really all we need to do is to figure out what kind of an experiment we're going to do, how we're going to collect the data, and how we're going to evaluate results. That's what the answer needs to include. So with the experiment, the farmer has 30 acres of farmland, so he could use all 3 methods. Each 10 acres would have a method. He'd use the traditional method as a control group, and he'd conduct the experiment for 1 year. Okay, I need to collect data to show whether that hypothesis is correct or not. So I'm going to say I'm going to measure the topsoil in each group monthly, and I'm going to record the data in a log so I can compare them. And then to evaluate, I'm going to analyze the data to see how the two variable methods, compare to the control group. If students can do that, they have everything they need to earn good points, to earn up to 3 points on this particular short answer. As Susan and I have worked with teachers, one of the things that we have found when we look at experimental design in the short answer portion is that teachers want to say, oh, but should we do it for a year? Should we do it for 6 years? No, the student here has determined a length of time which is appropriate. Or they may say, well, 10 acres enough. Quite honestly, what the prompt has given us, the source text has given us the fact that there's 30 acres, it really is just very reasonable to say I'm going to break it up. So if I look at what earns points in this particular short answer, you'll notice again that there are some adjectives: minimal, logical, or well formulated. And for each of those adjectives, you'll notice that the other things are very similar. Either it's a minimal explanation of the controlled experiment, the data collection, and the evaluation, or it's a logical, or it's a well formulated. This particular answer tells us that the farmer could set up an experiment to last 1 year, include all 3 methods. 10 acres would be set aside for each of the 3 methods. You'll notice that here, this particular test taker has used bulleted points. Absolutely no problem. It's very clear what the student wanted us to understand. So we've got that beginning of the experimental design. Farmer is going to identify 3 areas within each group where he would measure the topsoil on a monthly basis. This way he could get an average for each group each month. He'd then record the data in a log to review at the end of the year. We have a very well formulated data collection method. And then finally, we have, based on the data collected, the farmer would be able to determine which of the 3 groups saw the least erosion and determine if his hypothesis was correct. Again, a well-formulated explanation of evaluated criteria. This is what it would take, or at least one option of what it would take to get all 3 points. As Susan and I said in the other short answer, it could be much shorter than this as far as length and still answer the question quite well. But when we look at this particular one, it really is 3 specific areas and either minimally, logically, or well formulated in the answer. You know, Susan, that doesn't look too difficult.
Well, Bonnie, I just have one question. Would I really have to go all the way to doing like 3 areas and getting an average? Could I just say that I was going to measure the topsoil in each of those areas, you know, just one place? Would that still work?
It would still work. I would like to see my students say that you would measure the topsoil on a monthly basis and put it in a chart.
Okay,
That would still give me the data collection method.
So I wouldn't have to do, like, you know, putting that fancy word average in there. I wouldn't have to do anything like that. I could actually have shortened that and not a problem.
What you and I have often told teachers, and we strongly believe this, is as I read an answer, I want to be able to replicate the experiment. And so if the student told me that he or she would measure the topsoil on a monthly basis and put it in a chart, I could do that. That's the type of answer we want to see on this. Can you replicate what the student is asking you to do in the experimental design?
That makes perfect sense. And I think that for students out there, you know, it really does come back to, you know, okay, I do some practice items and I write up my response and I give it to somebody else to read and see if they understand what I'm saying.
You know, that's so true. And sometimes it really isn't that difficult. A good friend of ours, Steve Schmidt out of Appalachian State, uses an experimental design graphic organizer. And he's found that with his students, something similar to this or similar to what we had used previously really helps his students in working through the whole experimental design process. And remember, it's not just about short answers. Students also have to be able to answer these types of questions in all the technology enhanced items as well.
So Bonnie, let's talk a little bit about the scoring rubric, because the ones that we just looked at, those were, each one was different. So I think it's important as we go through that everyone remember that each item is going to have its own rules for scoring. So, they do the scoring guides, they develop those when they're developing the item itself. But, you're going to see something very different for the scoring between an experiment and one where you're just explaining something.
Very definitely. And remember that there again, this is content driven. The short answers will change. You're exactly right, from one to another. And although one of the things that was asked, that GD Testing Service says you should take approximately 10 minutes on each of these questions, they are not timed separately. It's just we know our students, and so we need to give them a general time frame. That's why when you look at the answers, they are not, very expansive answers. But students need to realize approximately 10 minutes, so if they're taking a lot longer, it really does take away from the rest of the test.
Okay. So do we have I think we have a handout. Can we kind of show people, because since we've just been talking about these, let's take a look at the handout itself. And
we will see. It was up there. Give me a moment.
Not a problem. One of the things that we wanted to make sure is that we provided you with some materials that you could take back to the classroom itself, and we'll work through those particular pieces. So as Bonnie goes over and she is moving things around.
Actually, it's not going to come up without me going out.
Okay, then here's what we will do. For those of you who've already downloaded, if you just take a moment to look at the information, resources, and strategies, the little handout that we have, what we've given you is, oh, there you go, Bonnie. Fantastic. You have the type 1, and you have the example there with all the information so that you can work with that. You also have an example, a sample response that you can kind of figure out for yourself. Which one, what do you think that particular one is? The next page, you have preparing the response, which goes into looking at what we just did with the experimental design. That's a great little simple graphic organizer for students to use that they can go through and plug in all that information. And as Bonnie said, then they have everything they need right in front of them in order to answer the question. We have provided you with the material from Appalachian State University that Steve Schmidt has worked with, as well as looking at a couple of other resources that are included in that. So, and I believe, Bonnie, if memory serves me correctly, we are missing a few pages in this.
It does look like it for some reason.
Yes, and I'm not sure why that is. So what we will do is we'll make sure that GED Testing Service has the updated book, and that way you have all the materials that are there, because we did include a number of different materials for online resources. But while we're here, Bonnie, could you talk just a minute about study jams?
Sure will. There's a couple resources, and we apologize because as I printed out everything printed out perfectly. But a couple resources. Many of you are in situations where you don't have access to certain materials, etc. If you're in correctional facilities, oftentimes that, of course, can be an issue to have any kinds of hands-on. So there are a number of resources that can work very, very well for you as well as others. If you have access to being able to either download videos or use videos in your classroom, Study Jams, which is out of Scholastic, is absolutely wonderful. It's got excellent videos on such areas as the scientific method, but it also has short videos on different areas of science, biology, physics, chemistry, etc. Both engaging as well as informative for students, and so a great site. The other one, TED Ed lessons. Don't overlook the fact that TED Ed has some fantastic science videos along with all kinds of worksheets, questions, etc. It's really important that students understand some big ideas of science, so these are great things to get started with. When you look at the other page, we've provided you with a number of different resources such as Newton's Apple, Discovery Education, Mythbusters, also from Discovery Channel. These are all places to go in and get different experiments that you can look at. Again, if you can download videos so that students can see experiments happening if you can't do them in the classroom, things like Newton's Apple, Steve Spangler are wonderful. The other thing is, and we've said this one more than once, is Newsela. Newsela provides some great reading comprehension articles and work very, very well in the classroom. So there again, you've got lots of options of things to use that work beautifully for our students in science. Daphne Atkinson often says it is not about an end-of-course exam, and that's really true in science. There's no way we could teach 4 years of science, from biology to chemistry to physics to anatomy. It really is about the big ideas, and the same thing goes with scientific method or scientific design. It's about the big ideas of that rather than sometimes the very specifics that a scientist would use. Same way with the short answers, as Susan was talking about with the narratives. It's about being able to make relationships and to really closely read. So Susan, I know we have a lot of questions out there.
Yes, we do. We have a lot of them. And so I think what we're going to do is take on these questions. We'll just go down the list. So shall we go ahead and get started?
Sure. So one of the first questions that we have is, do you know if students will be able to see their scores on the short answer questions when they take the GED science test? And what percent do the two short answer questions count of the total GED science test?
Okay, no, they cannot see their scores on the short answer question. I think we talked about that. But to be clear, it's percentage-wise, both of them together count as approximately 15% of the total GED science test score.
Okay, and the next question, just to clarify, can a student see how many points out of 3 possible they get right for each 2 short responses?
This is Daphne Amber. No, they can't see them because really the short answer, unlike on RLA, these are just another question type inside the science exam. They don't sit apart from, they're not in their own separate section or own separate module. Just think of them as another question type within the science exam.
Okay. The next question, can you differentiate between the observation before the experiment and the observation afterward?
The observation before is the fact that we observe issues in the world around us. We observe problems. The observation afterwards is what did you observe happened from the experiment, from the data collection.
This question is for someone who's in the prison system, and they want to know, and they said that it's hard to do the scientific method. What can prisons do to cover this area?
You know, both Susan and I have worked with corrections for many, many years, and sometimes the scientific method can be as simple as one of the experiments Susan and I have done, all you need to have is paper. And being able to see, and again, it's really dealing with what falls to the ground first and why, that experimentation process. So as you work in a correctional facility, if You cannot show short videos. Then again, with the experimentation process, do an experiment with materials that are available, such as, like I said, we did an experiment on wind resistance, and all it took was paper, which most of the time we can use. So it doesn't have to be things where, you know, we need the lab, or it doesn't need to be experiments where we're really looking at materials which would be, quote, contraband, but rather materials that can be used. Experimentation can even be something as simple as what Susan and I were talking about with the car, which most of our folks would know about. So if you can't do something hands-on, get those real-world situations. Taking them through that once or twice would be invaluable for them as they see in real world what some of those terms mean. Susan, any other suggestions?
No, I think that really, you know, it's about trying to make the most of what you have,
Yes.
and doing something that, you know, is very much real life. Even talking through a real life situation, just like we did with the car. I mean, those are the kinds of things that you can do. It's about getting the thinking process going.
Okay, and the next question, about how many sentences are students writing in their answers to short answer questions?
I think we kind of covered that. However, enough to answer the question. Unlike RLA, again, it really isn't that GED testing service is looking at a certain length to adequately support whether students have certain skills. As Daphne said before, these are basically the same types of questions that we see in technology enhanced little format, but again, they're looking for a correct answer, to put it very simplistically. So again, however many sentences it takes. Susan and I have seen in the GED testing service materials some answers that are just a couple questions or a couple sentences, but that answered the question, you know, at least maybe at a 1 or 2 point level. It takes a few more to get that 3 level, because I don't think I'd have to be really good to put those 3 segments of a short answer for experimental design into one sentence, but I probably could do it okay in 3 to 5.
Okay, so the next one is about hypothesis. And she's saying that her class tries to make hypothesis in the form of a question. Any suggestions on how to get them to stop making it into a question and to serve it as a hypothesis?
You know, my first reaction would be they're asking the question for the experiment, then just give them the if then template and tell them to put their question in the if then format, and that will take it out. But asking the question really is that important first step. So you know, hypotheses take many forms, but it does come down to if I do this, then this will happen. So that would be my first suggestion, is to have them take those questions and put it into that particular format. And by all means, first we need to take those questions and put them in the format, model it for the students, have them again work with us, and then keep your fingers crossed that we get that if-then format instead of a question.
So the next question is related to scientific formula question, and I believe you may have touched on this, but just want to ask it just in case. Are there any formulas related to solving a scientific equation that students should try and memorize or focus more on to help them with passing the science exam?
And Daphne can feed in a moment, but no, not that I know of, because this is not a recall test. So if I were you, I wouldn't worry about them memorizing formulas. If there would be any formulas they would need to use for any reason, it would be provided to them and they would need to apply. but otherwise, no. I think sometimes we worry about scientific formulas that support certain theories, and there again, it's not an end of course exam. So I would spend my time working more on those big ideas of science rather than worrying about will there be some formula, because again, that's not within those assessment targets. Daphne, any other comments you would have about scientific formulas?
No, I would echo exactly what you just said. This is about reasoning. So, it's not a recall test, and it's not, like Bonnie said, it's not an end of course exam. But students do need to be familiar with, Bonnie calls them big ideas, I call them the fundamental concepts. And they need to be able to apply them when they're presented with information about them. We've taken a lot of the burden off students, like the bad old days when I was in school, where we memorized the order of elements in the periodic table. For what purpose? I am still trying to figure that out. But we don't ask them questions like that. And if there is something that that needs to be served up to them, we serve it up as part of the text of the question. And that includes, conversions, that includes, formulas, but students still have to be able to reason and work with the concept and the information that's presented as part of the question.
Okay, so the next question, this person, he teaches GED classes in Spanish, and some of his students have problems with Spanish grammar. How does the grammar impact on writing? How does the grammar make an impact on writing this sort of answer exercise?
They are not assessed on grammar, on the short answer. So consequently, what we're looking for is it readable? Does it make sense? Daphne's my guru of grammar here. However, if the sentence would say they is, it's not going to count off. It is about content.
Yes.
Daphne, you want to?
Yes. No, it is. I mean, we would hope that students would write as grammatically as possible. But, to the extent that the grammar, as Bonnie just said, does not get in the way of the reader understanding the student's answer, then it is not a problem. Where the answer is incomprehensible because there are, the words are out of order or cannot be understood, or whatever the case may be, that may cause a loss of points. But as long as the answer is comprehensible and it can be determined that the student was answering the question that was asked, grammar is not part of the scoring mechanism for these particular items.
Okay, the next question, because some of the scores may be subjective, what training do the actual score takers go under or undergo?
Daphne, do you want to take on how these are the scoring of the scientific responses?
Well, it's actually not as subjective as you would think, because if you take a look at the scoring materials that we have out there for science, it's pretty clear what the expectations are for each scoring level. Complete, concise. I mean, complete support from the text or the table means complete support from the text or table. That's not actually arbitrary.
Okay, so hopefully that helps in taking a look at that. So next question.
So the next question is, how do you get students to avoid repeating the content of the prompt for the question they are asked? Not sure if you guys covered this one.
Lots of practice.
that Daphne absolutely summed it up. Lots of practice. I mean, it comes back to yes, students have a tendency to want to just put that response, the prompt, write that in there as if they want to let somebody know I'm answering this question. And so it really is about getting students to understand what the prompt is asking them to do, and practicing with them in different settings, using different materials so that they can do that. It really does come down to practice.
And it also is the part of the practice drill is also for you to be giving constructive feedback to students when you see them doing it. Okay, so and sending them back to rewrite an answer based on the feedback that you give them. So it's a two-step process. Not only getting them to do it enough that they feel comfortable and confident doing it, but also providing them with feedback and redirecting them when they get off task or off topic.
Okay, so the next question is about the short answer and the minimal, and is there a minimal word count, and are there two short answer questions on each test of one of each type? Just clarification on that.
Okay, and the answer to the second one, there's one of each type, so there are two short answers on the science test, one of each of those types that we discussed. And as far as minimal word count, no, there is no minimal word count. It is about responding to what that prompt said. So as Bonnie discussed earlier, you're not going to be able to convey that in a sentence, or 10 words or less. It really is going to be that you need to know, evaluate that prompt, analyze what it's asking you to do, and respond from there.
This question, the person noticed that many of the books do not teach physics, yet on the test there are a number of physics questions. Why is that?
Well, that would be up to the publishers.
Yes.
If you take a look at the materials that are on the GED in the GED marketplace where they do the references out, the materials that most closely correlate to the GED, they have that kind of seal of approval out there. So I would take a look at those. Keep in mind that when we talk about physics, that we need to look at it from a standpoint of that application. How do different things work, as opposed to getting into maybe some of the finer points. But if the books that you have aren't providing anything in those areas, then I would take a look at other materials that are out there.
And as Susan said, yes, there is physical science and things like work and force and motion. Those are some of the big ideas of the physical science area. May not be at that top level of physics that we often think of in a high school setting, but physical science, you are correct, incorporates some chemistry, some physics. So it is as Susan said, application oriented.
Okay.
And I would suggest you look at the themes for science, because you'll see those big ideas for physical science. That may assist too in determining what kinds of materials may or may not be in those books.
Okay, the next question is about how important is grammar, sentence structure, punctuation, capitalization, etc., in creating a high score response?
And I think probably we've covered that quite a bit with the fact that, as Daphne says, as long as it is readable, as long as the reader understands what the student has done, it is not directly assessed.
Keep in mind that with the science short answers, it's about the student's ideas. what they've conveyed, the information, the explanation, or the experiment. And, the assessment of all the grammar issues, that comes back to RLA and the extended response as compared to here. Now, if you have something that's totally unreadable, then how are you going to get anybody to understand your ideas? So it's important from that aspect that students, are careful in their writing and that they proof and that they edit what they have written so that it's clear, but really, focus in again on the ideas here as opposed to the finer points of grammar.
And I know there was a comment about that students have to determine that they're using 20 minutes, et cetera, without any prompting, et cetera. Remember, there is a clock so they can watch their time. Some teachers will recommend that their students do both short answers at the end, some as they come. But the big thing is that students just do not use an inordinate amount of time for these short answers because they're not expected to be extremely lengthy.
Okay, and then the last question that we have is, do you know how many questions on the exam are balancing chemical equations?
Possibly none.
There might be one, or there may be none.
None.
Keep in mind that there's a lot of, and I know where this kind of stuff comes from, because on the item sampler there was a chemical equation that was on that item sampler, and I think that probably sent all of us a little bit like, oh, what is this? But no, let's, as we go back, let's focus in on the things that are the most important when we take a look at these. And as I think I heard Daphne say, none as well. But
yeah, I mean, it just, I mean, the content from exam to exam is, pretty standard. But exactly, whether something is or is not there, we may choose to test that concept with another type of question.
True.
Mm-hmm.
I mean, this is really more about concept and understanding and reasoning than it is about, every single test form having a question type or a question about balancing chemical equations. We may find another way to ask that question, and that requires the same degree of reasoning because it's about that, not necessarily a specific question type.
Okay, and it looks like we have from David Stanley, who says that there has been some students who've come back and said there was one that was on there. So again, out of all of the questions, I think, what we tend to have are students, just like on math, they will tend to remember that one thing as opposed to having so much of the other questions. So I think, again, I would focus more toward taking a look at the big ideas and looking at those focusing themes.
Susan, let me make another observation that it's really important for everyone on the call to remember that unlike the old world that we had, where the only performance level was high school equivalency or not, what we have now is each of our content area tests, there are 4 possible performance levels that students can come in at. And so, although every form is constructed to allow those at the high school equivalency level to achieve that level on the exam, if they are functioning at that level. Keep in mind, we also have College and Career Ready, which is performance level 3, and College Ready plus credit, which is level 4, which is your top level. Those are the folks that are scoring 165 to 200. So there are going to be some items that are really for the folks who are performing at those higher performance levels, and your students should not be undone if they see them. They should answer as a good piece of test strategy, they should answer the questions that they know they can answer correctly or can reason to an answer correctly, and do not get put off track by spending 20 minutes on an item that may well be above their ability level. And by the way, your students are not supposed to come back and tell you about exam questions. They sign a statement that says they won't do that. But we know they do.
They may not. They may sign that statement, but Daphne, you know as well as I do that they just have to share that little piece of information as they go through. But Daphne, I want to, because I think I've seen this question before, so I want to make sure that we get this one right. Okay, so we've told everyone that in science, no, they're not going to see how many points they get for each question. However, the question has come up now about the RLA extended response. Do the examinees get in their enhanced score report how many points they earned on the RLA extended response?
Yes, they do.
Okay, so I think that will make Donald very happy. But the other thing is they don't
get
but
I will say, although they get the 4 points that they earn for each of the 3 traits, they do not get a copy back of what they wrote. And neither can instructors access that, because that would be a test security problem for us.
Absolutely. But I think the main thing here for Donald was concerned about, you know, that students get those, that they're able to see the number of points on the RLA extended response. And yes they do. And so then that tells the student, you know, if I get 0 points on trait 1, I've got to do some work on trait 1. And so that is there. The other thing, the other question that Donald has is, will there ever be a time when they'll know how many questions on the test they got right or wrong?
No.
No.
There probably will not. And that's because all testing programs, there are 2 kinds of score points. There are raw score points, and then there are scaled score points. What you see on the score report is a scaled score or scaled score point. And what happens is that the raw score points, as is true with every standardized testing program, undergo a proprietary algorithm to actually yield your scaled score points. So no, there will not be a time when, and for, you know, for all of those things, just to know how many you got right doesn't really tell you much about, you know, what it is that you need to be working on. And the enhanced score report actually gives you more information content than GED test takers have had for decades.
Okay, so let's do a little follow-up here. Do you know, Daphne, where on the My GED, the enhanced score report, they're going to see where those number of points are for the extended response?
Yes. If I remember correctly, it is when you are in their score report dashboard, there is I think there's a header that's called My Written Responses. And you have to access that to see it and to get the feedback for, you know, each of the 3 traits.
Okay, great. So that will, hopefully, Donald, that helps in giving you some ideas on the different things that are there.
Let me also say that if you have your students at any point use GED Ready, it is invaluable for you as instructors to really provide students with feedback on their writing before they sit for operational testing. And that is why we have something on our website called, called the Educator Scoring Tool. It is actually designed for you to be able to score their written responses for GED Ready. There's a scoring template and an explanation of how to use it. We highly recommend that if you do have your students use GED Ready, or your students actually purchase it and take GED Ready on their own, that you ask to see their GED Ready essays. You, as instructors, have access to the prompts and the materials on GEDtestingservice.com. It is one of the resources. The only thing we ask you to do, not to do, is to share them broadly in your classrooms or use them for practice. But they are there to aid you in scoring student responses, written responses for GED Ready. I urge you to make use of that, because then you can provide students with structured feedback on their writing before they sit for the real thing.
Okay, so Daphne, thank you so much for providing clarification on that. Amber, do we have any other questions that we need to cover at this point?
I think
one of the questions I saw, Susan, I was going to say, I saw whether the short answers were hand scored or computer scored. That was back a ways, but I don't think we've answered that one.
I think this was a clarification question about it being scored.
And Daphne, is that the science or computer scored, correct?
Yes.
Okay, yes, they are computer scored.
So we have, someone's asking about where is the prompt, and they want to know where they can see their answers. I think they just want clarification on what we were just covering. And then also, Daphne, can you kind of repeat what you were talking about as far as where educators can go to get that scoring tool?
Okay, so on GEDtestingservice.com, under Teaching and Scoring Tools, there will be, for the content areas, there's an educator scoring tool. That's where you get it. You can download that. For, if you use GED Ready, or your students take GED Ready, you actually have access as instructors to the materials associated with the current prompts being used with GED Ready. And I think that we ask you, to fill in a little bit of registration information, and we ask you not to use those materials as training materials in class, because if your students are actually using GED Ready as a readiness indicator, it'll compromise the value of that. Okay, so that's where you get those materials. And so providing students, the idea is that you will see what the performance flaws or the performance pluses that your students are exhibiting before they go to operational testing. And the science prompts are there, as well as the materials for RLA.
And I actually just provided a link to the scoring tools in the chat box for everybody.
Thank you for doing that. Because I don't remember the URLs off the top of my head, but I can find them, if I'm in front of a computer. And so make use of make smart use of those tools, because to the extent that you can give students concrete and detailed feedback on their writing before they test operationally, they have a leg up in delivering better performance when they sit for operational testing. These are the kinds of things where practice does improve performance. And familiarity also improves performance.
And one other comment that I'll make, just so that we don't forget it, because we're getting close to the end of our time. Amber has, into the handout section, she has input the correct short answer workbook. And so we made sure that we had the revised copy there for you. So before you leave, if you want to make sure that you get this one, the book should have 13 pages in it. It should not have 7, which is what happened with some of the others. So I'm not real sure what happened in the conversion over to PDF, but the correct one is there now.
I believe the last question that we have, are the Spanish test short answers also scored by computer?
You know something, I don't know the answer to that. I know that the RLA, in RLA, they are not scored by computer. They are human scored. And I suspect that the science may be the same.
And I think we've had a couple questions of, will there be new science sample questions out, or where can we get other samples of short answer exercises? Since I know we've been using the Farmer and the OU for quite some time.
Well, that will depend on the generosity of assessment services. What I do need people on the call to understand is that when we provide those sample items, they are items that have been active test items, and they have to literally be decommissioned. And so I certainly can put in a plug for us to have some new materials out there, but it will actually depend on whether our assessment services colleagues can release those items.
Oh, we do have one question here that says, whoa, the RLA are human answered, and so no, the only RLA that are human scored are Spanish version, not the English
Correct.
version. Okay?
Correct.
So make sure that, yeah, because the others are all computer scored, so I want to make sure we don't have any misunderstanding. Okay.
Okay. Wait a minute. The only time that an RLA response in English may be human scored, there are two circumstances. A test taker asks for a rescore, or the test taker has provided an answer that does not match any of the thousands of responses that we have in the automated scoring engine's memory. And in that case, an out-of-the-box response is actually kicked out to human scores to determine a score. That is the only time that happens, and it happens rarely.
So this next question is about the workbook, has odd pages. This current workbook, the workbook that's uploaded, it is 13 pages, and it should be the correct one.
Yes, it is, because I just pulled it down from there, so you shouldn't have, there shouldn't be any problem with going for that workbook.
And I've just pulled it up, Susan.
Okay.
And it looks like there's 13 pages here, and
yes,
they are all here, guys.
Okay, and it looks like those are all the questions that we have.
Then I'd like to thank everyone. What great questions as we went through. As Daphne started out, yes, this is the last webinar for 2016. Coming in 2017 will be new webinars as we go through and do more and more Tuesdays for Teachers. But before I turn it back over to Daphne and Susan, I'm going to wish all of you a wonderful holiday season, and we'll see you in 2017. So, Susan.
I echo what Bonnie said. Have a wonderful holiday, which is fast approaching, and I still haven't bought any presents. But we look forward to seeing you in 2017. Have a great and happy and safe New Year as you're moving through. Daphne?
I'm just going to say ditto, and we will look forward to seeing you again in 2017. Take care. Happy holidays.